Hello, welcome to this video. So this problem will be about a conventional question about complex numbers and also about quadratic equations. Okay, so and then for part A, so you can see we have 1 over 1 plus 2i. So we see complex number I in the denominator. So of course we need to do the rationalization of the denominator. So the way to do the rationalization of the denominator, so if the denominator is in the form of a plus bi, then we try to multiply the numerator and denominator by 1 a minus bi. Okay, so in this case we try to multiply the numerator denominator by 1 minus 2i. And then for the denominator, so using a squared minus b squared, so that will be 1 minus 4i squared. And then since I squared equals -1, so that's why here, so that will be 1 minus 2i over 5. And then splitting, the two terms, so we can get 1 over 5 minus 2 over 5i. So this would be the best form because if you try to refer back to the question, you are asked to express the complex number in the form of a plus bi. So that's why part A in this form will be perfect. And then for part B, B1, so 10 over 1 plus 2i. So we are given two fractions in which the two very ugly fractions, so the two ugly fractions here would be the two roots. It's like alpha and beta. But before we handle the roots, of course we try to simplify. We try to simplify the two roots as we can. So 10 over 1 plus 2i, so basically it's just like 10 times 1 over 1 plus 2i. So it will be equals to 10 over 1 over 5 minus 2 over 5i. And then that will be equals to 2 minus 4i. So and then similarly, 10 over 1 minus 2i. Now I'm not going to redo the rationalization in part A. So the rationalization is similar, so that's why we just try to turn the minus sign into plus sign. So the second root after simplification, it will be 2 plus 4i. And then we'll try to consider the sum of roots. So for ax squared plus bx plus c equals 0, so sum of roots will be negative b over a, and then product of roots will be c over a. So that's why sum of roots here will be negative p. And then sum of roots, so root 1 and then root 2 equals negative p. So and then of course these two terms cancelled, so that's why negative p equals 4, so that's why p equals negative 4. And then we try to consider the product of roots as well. So the product of roots will be given by q. So and then that would be 2 minus 4i times 2 plus 4i. So and then that will be using the difference of identities. So that would be 4 minus 16i squared, so that would be 4 times 16 times negative 1. So that's why q equals 20. And that would be part B2. Part B1. And then B2, so x squared plus px, so p will be negative 4, find in B1, and then q will be 20. And then we try to rewrite this equation back to its corresponding general form. So and then because it is given that the equation has real roots, so the delta will be bigger than or equal to 0. So b squared minus 4ac will be bigger than or equal to 0. And then we try to remove all the bracket. So and then 4r bigger than or equal to negative 64. So that's why r2 divide both sides by 4. So that would be just 16. 18 minus 16. So 64 divided by 4, 16, right? And that would be the corresponding or the required ranges, okay, of values of r2. And then this part is also done, as well as the whole question. Okay, the whole problem is done. Thank you for watching.